look at this question. A electric heater is to be made from nichrome wire. Nichrome has a resistivity of 1.0 times 10 to the minus 6 ohm meter at operating temperature of the heater. The heater is to have a power dissipation of 60 watts. When the potential difference across its terminal is 12 volts. A. For the heater operating at its designated power, calculate 1. The current. 2. Show that the resistance is 2.4 ohm. So we go to the first one. We want to calculate current. How do we go about this? We were given power and voltage. So we can express the power dissipation in terms of voltage, power, and current. What would that give you? Power is equal to what? IV. What is the power here? 60. Current, you don't know. Voltage is 12 volts. Therefore, current becomes 60 over 12. This will give you what? 5 amperes. The current is 5 amperes. That takes care of that. Show that the resistance is 2.4 ohms. So we can equally express, with no voltage, with no current, we can find resistance using V is equal to what? IR. Otherwise, so we can just say that since V equals IR, the potential difference is 12, current is 5, resistance we don't know. So R becomes what? 12 over 5, which is equal to 2.4 ohms. And this is what you're asked to show. Resistance equals 2.4 ohms. Then the next one is calculate the length of nichrome wire of diameter 0.80 millimeters required for the heater. So we want to calculate the length. The diameter of the wire is given. From the diameter of the wire, we can calculate the cross-sectional area. The cross-sectional area, don't forget, is given as this is I, this is II. Don't forget that the cross-sectional area is given as pi r squared, which is equal to pi d over 2 all squared, and this will give pi d squared over 4. So that is the cross-sectional area. So since you know the value of the diameter, we can easily calculate its cross-sectional area. And if you know the cross-sectional area and we know resistance and we know resistivity, then we can find the length using resistance is equal to what? Rho L over what? A. Resistance is equal to rho L over A. Therefore, resistance is rho L over A. Therefore, L is equal to what? RA over what? Rho. So the length is basically RA over what? RA over rho, which is R, what is A? Pi d squared over what? Over 4 rho. So we can substitute now. The resistance is 2.4 pi. What is D? Is 0.80 millimeters. We convert that one to meters by multiplying with 10 raised to power minus 3 all squared over 4 times rho. What is rho? Rho is 1.0 times 10 raised to power minus 6. So we can use our calculator now to find the length. In using your calculator, don't waste time. Use a very good scientific calculator. You start with the fraction symbol, which has numerator and denominator. Put all these things at the numerator. So you have 2.4 times pi times 0.80 exponential minus 3 all squared. That is squared. Then you come to the denominator. You have 4 times 1.0 times 10 raised to power minus 6. You go to the equal sign, and that will just give you 1.206. 1.206, approximately 1.21 meters, which is the length. Then Next one now is that a second heater is operated from a 12-volt power supply, which is having the same voltage as this, using the same nichrome, meaning that the resistivity is the same, but half its length of that calculated in B. Explain quantitatively the effect of this change in length on the power of the heater. We know that if the length of the wire is changed, the first property is going to affect is the resistance of the heater. Then the resistance of the heater will then affect the power of the heater. So in order to explain this, we need to understand that the power supply is constant. So we are looking at the variation. We need to understand that the voltage of the power supply is constant. So in order to now explain how power is affected by resistance, we need to use the equation relating power to resistance at constant voltage. I repeat that. The question is asking you what is the effect of reducing using a length of using a nichrome wire having half the length of the original one. If length is altered, it will affect the resistance. Then resistance will affect what? Power. So we are looking at variation between power and resistance. And if you are comparing between two variables, you have to have a constant. What is the constant in this case? The constant is the 12 volt, is the voltage. So we need to use the relationship between power and resistance at constant voltage. What is that relationship? What is that relationship? That relationship is basically power is equal to V squared over what? Over R. So from this relationship, we can see that power is inversely proportional to resistance at constant voltage. Voltage is constant. So we can therefore answer the question that if the length is halved, resistance is directly proportional to the length. So we know that if the length is halved, if length, let me start writing from here. If length is halved, resistance will be halved. Will be what? Will be halved. Because resistance is directly proportional to length. Is that okay? Therefore, power will be doubled. Power will be doubled because power is inversely proportional to resistance at constant voltage or at constant PD, which is the answer there. So the answer to this question is that the power will be doubled, but you cannot just arrive at that. According to what I've explained to you, what with the changing the length is going to affect the resistance, directly proportional. So we are now looking at what equation explains how power changes with resistance. The third one must be a constant. So I cannot use this equation to explain it directly. I cannot use the equation of power like P is equal to I squared R. Because if you change, you don't know what is constant there. You cannot use that. So the most appropriate equation to use is P is equal to V squared over R, because this is constant. Therefore, I can look at the variation between these two. So we look at how this changes with length. The length is halved, so resistance will be halved because resistance is directly proportional to length. Is that okay? Therefore, the power will be doubled because power is inversely proportional to what? Resistance at constant PD.